All right, so on to the next problem. So question 2, solve the following problem. So this is the problem, and we're gonna find out the LTP. Now LTP, or I think they meant to say LTF. So let me correct them real quick over here. So it's gonna be LTF, which is short for the low taper fade. So you know that triangles add up to 67 degrees. So these two are 67, as well as this one that's inside the square. Now this brain rot is a unique one because it has a circle, and circles are 41 degrees. So it's split between an outside and an inside one. The one that's inside, so it's gonna be, so the circle equals to 41 degrees, but half of it is in the brain rot core. So we know that a circle equals to 41 degrees. So we're gonna do 41 divided by 2, which will give us 20.5, which is in this part. And we know this is 67 degrees. So we're gonna add 67 to 20.5, and we're gonna get 87.5. Now we have to add up. We have to figure out what this square is. This square over here, the bigger one. This square. Now, we know that a square is equal to 61 degrees. So we're going to write that down. And we're going to add 61 plus 67 plus 87.5. And we're going to get 215.5 degrees. Now, that is going to be our low taper fade. So 215.5. Now, these squares that are connected, we could say these are a trapezoid. These are there to just throw us off, but there also is a question, or it can pop up, which is solve the exterior low taper fade. If that's the case, then we're going to have to add up 67 times 2, or 67 plus 67, which is going to give us 134 degrees. So that's going to be our exterior high taper fade. But they didn't ask us for the high taper fade, they just asked us for a low taper fade. So there is our answer.